Everything looks good now.
Hi, everybody. Kent Marts here from Explore Scientific for Wednesday's episode of FirstLight Chronicles. I have with me today Scott Roberts, the founder and president of Explore Scientific. Scott, are you there? There he
I'm
is.
here. I'm here.
So
Still wobbly after the 99th Global Star Party, but
yeah,
that was a. Go ahead.
we just had a false start, it looks like, on getting going and realized that we weren't getting any chats, and that was a clue. We weren't streaming. So, Scott, you were up with the global. Yep. Windows Defender apparently booted us for some reason, Paul says. But, Scott, you were up with the Global Star Party last night, got done before midnight. So that was the 99th one. You had a good time and had a great lineup. But, man, I'm on the email list of everybody, the invitation list Scott sends out responses. Scott, you got a big lineup coming for next week, which is the 100th show. What's going on with
everybody, all these speakers want to be on the 100th program, which is great. Many of them have done, I don't even know how many shows. David Levy has done every one of them except for one. And I don't even really count that one so much, except that this was a International Observe the Moon Night event that was done by Night Sky Network, and it was, I believe, an oversight from the person doing the schedule. Either they didn't get the message that David Levy would do it, or something happened, but he wasn't invited. And I wasn't the guy doing the schedule. So anyways, but we love David. David's like one of my best friends in the whole wide world. And he has done a phenomenal job all the way through. He is, so people get to see him on our programs every week. But also with the Arizona Dark Sky Star Party, there it is, poster back there, you're actually going to be able to observe with him and meet with him and maybe get a book signed by him if you'd like. The 99th Global Star Party went kind of long. It went till about 11 o'clock at night almost, and had all the speakers were there except for the very last one was Bob Fugate, and he had some family issue he had to deal with. So, but Adrian Bradley filled in for him and showed some of his beautiful nightscape work and that kind of thing. So it was good, all good.
So next week is the 100th, and there's a lot of some potential. 100 is a significant number for us.
Yes, it is. Yeah. So 100 global star parties. There's a lot of programs that have been on YouTube and, social media that have also shared astronomy, live astronomy, that kind of thing. I think that if we're not the most, prevalent one, we're one of. So that's, to do 100 of these things, there is so many. I mean, there's literally hundreds and hundreds of hours, maybe over 1,000 hours of great information from speakers like Gary Palmer, Molly Wakeling, Jason Genzel, Chuck Ayub has been on the program. We've had JPL scientists on the program. Next week, we will have the principal astronomer from the SETI Institute. That's the Search for Extraterrestrial Intelligence Institute. And I think it's going to be great. He is a fantastic speaker. His name is Seth Shostak, and so that's just one of the people that's going to be on. But you're going to see a lot of familiar faces coming on next Tuesday.
So, are we giving away any prizes, Scott?
Oh yeah, yeah. So, so this is the
I thought
100th
so.
anniversary, not the 100th anniversary, the 100th event. I keep calling it the 100th anniversary. We have the IXOS 100 mount, so we will be giving away an IXOS 100. We have 100-degree eyepieces, so you can expect a couple of those in there. So we will make it special.
You know, for those of you who don't know, the IXOS 100 is a go-to tracker mount. Great
Right.
for if you have a DSLR and a camera lens, you
Yep.
can get into some tracking, so you're doing longer exposures. And if you've got like an ED80 or something like that, right in the wheelhouse for really getting into astrophotography and learning the ropes. It's also, Scott, as you well know, very powerful because you can wire it to a computer and do some incredibly high-end work with
Yep.
a mount that retails for $599.
Right.
You know, it's just a fabulous tool, and you know, more and more of them are out there, and we're seeing just some astounding pictures that people
Oh
have
yeah.
gotten using.
Yeah, Wade
the
Prunty, who
100.
follows this program, did a 100-hour exposure. Of course, stacking and tracking, but still really put that thing through its paces. With a lot of equipment mounted on it.
Right. You know, we rate it at 9 pounds for astrophotography gear and camera and all that stuff, and 15 or 16 pounds for visual. But people oftentimes don't really take our limits seriously. And
Mhm.
JR lives down in Louisiana. He is running a 180 millimeter Maxitov Cassegrain and camera gear on the Exos 100, running with 24 pounds of gear on his
Wow.
telescope, and has added extra counterweights to get 18 pounds of counterweights.
Oh
Doing
man!
planetary,
And he's doing
running at like
astrophotography with that rig.
doing planetary astrophotography, working in the 5400 millimeter focal length range with
Man,
with an IXOS 100. Yeah, so it is, you know, a powerful little device that we have out there. So
Pekka wanted to know if this is live. Hi, Pekka. How are you? Yes, it's live.
it's, I guess, Scott, I think we're running into, because we've been doing some recorded broadcasts that were live.
Yeah, we have some.
Uh,
We are broadcasting. It says live because we're streaming it live. Uh,
it-
but we have pre-recorded stuff that's out there too. Just
so
for the people that
it's
have missed a bunch of the other programming we've done.
yeah, it's pre-recorded live, and so it says live. Like this broadcast, we'll run this broadcast in the future, and up there it says live, but
Hmm.
we have a little bug that says pre-recorded on top
Yeah,
of or close to it.
previously recorded. I usually
Previously,
stick that
yeah,
up there.
yeah.
Yeah,
So
but I
if
think
you see
people are missing
that,
that.
then definitely that's not live.
Right.
Right. So
It's not live
got
live
that
where Pekka can wave to us, like he is right now.
right.
So
Exactly. All right, so that's coming up. This is FirstLight Chronicles. We have a FirstLight series of telescopes, which gave its name to this broadcast, and it's
hmm
sort of become, how do you get into astronomy and things like that. And James Webb Space Telescope had FirstLight yesterday, really on Monday a little bit, but really strongly on Tuesday. And it is a real popularizer and draws people to the idea of astronomy and astrophotography. I can do that. Scott, what's your advice for amateur astronomers out there who can capitalize on this moment of people being interested in it? And like tonight's the supermoon, it's a perigee moon, so it's going to
yeah.
be 13 or 14% closer and 30% brighter. People have been
hmm
asking me about it. What's your advice on how we can go about capturing this moment, this singular period of time, to get people into the hobby we all love?
Well, I mean, it's all about communication. First off, these live programs is a good start, but a good step beyond that is the tried and true join your astronomy club, and get involved with them. There are astronomy clubs across the country. We are strongly tied to the Astronomical League and the Royal Astronomical Society of Canada. And those two organizations represent, at least in North America, and also with memberships around the world, a very, very strong, alliance. They have the league itself, I think, has 300 clubs, over 300 clubs, over 20,000 members. The RASC in Canada has several thousand members as well. They're older than the Astronomical League is, but these are both organizations that have been around for a while. I think the Astronomical League this year is celebrating their 75th anniversary, and I think that the RASC has been around for over 100 years, maybe like 150 years, something like that. But being involved with an astronomy club is great. What if you can't be involved with an astronomy club? Okay. Well, there's nothing to stop you from starting kind of an ad hoc astronomy gathering. And I did that a long time ago. And literally, it was me going out to a street corner. And pretty soon there would be like somebody would kind of hang out with me, and it was just two of us, and then it became four of us, and then it became 20 of us, and then it became 50 of us, and then we had to go find another place to go observe from, which we did, and then eventually that group of friends, observing friends, became like 600. Okay, I was working at a camera shop called Oceanside Photographic Center at the time. We sold more and more telescopes, and the community got so involved that we changed the name of the store to be called Oceanside Photo and Telescope. They now go by their initials OPT, which you might have also shot from them. But it's really simple in getting involved. You did it yourself, Kent. How did you get started? I mean, you had a father that was kind of very interested, right?
Right. Dad would take us out, and binoculars, or just go out and watch meteor showers.
Mm-hmm.
Growing up in the 60s, hang on, I got an earbud falling out. Growing up in the 60s, now this one wants to fall out. That was weird. So growing up in the 60s, on the north side of a town that had a couple thousand people in it, down in the Arkansas River Valley, the skies were spectacular. And I don't remember them being like they are, but I think that memory fades. But I can remember comets, Bennett and West in the late 60s and early 70s,
That's cool.
just stretching, big knot, a great comet, a big, bright, obvious nucleus and a big long tail that stretches across the sky. I mean, the
Yeah.
comet Pan-STARRS that's out there, it's hard to see it in a telescope, especially right now because of the moonlight. But it's not a big obvious thing. People look up and go, "Oh my gosh, there's a comet." Well, with those, people look up and say, "Oh my gosh, there's a comet." We haven't had one of those in a long time, but we would try to do some photography on lunar eclipses and things like that, and just go out and hang out, which I really advocate as a great way to get a kid involved in
Mm-hmm.
astronomy. And it may be they go on with life and don't have that interest, but we see this really typically, Scott. People get in their 40s, 30s, 40s, and start getting that hankering for astronomy again and get back into it. We see that pattern all
Yeah.
the time.
Well, that's what Galileo did. He got started in astronomy when he turned 45. So,
So,
and he had a nice run at it, but which still
yeah.
affects us today. I really wonder what was Galileo's childhood like that got him interested in stargazing. I can imagine he was out, in Florence or wherever he was, and seeing incredible skies back then. I mean, no light pollution to speak of, right?
None, zero light pollution. I don't. I mean, how much light pollution can you have from
With candles?
Yeah, none. You might have
Not much.
when the industrial revolution gets going, you start having some air pollution that would have affected them,
Yeah.
but you still
Oh, yeah.
have inky black nights. I think his childhood was one of curiosity.
Mm.
There's an innate curiosity and a wonder people have, and if you're curious about things, I mean, he had to be curious about the telescope because he was like, wow. And he thought, well, I wonder what the sky looks like with this. And he looked at Jupiter and went, wow, look at that. He just, he looked at the sun and observed sunspots. And, I mean,
Hmm.
it's just, I think it's just being curious. And Scott, we saw this on Friday, had a couple come in the store, and the wife was wanting to buy a telescope and mount for her husband for their wedding anniversary. And we were talking to them, and they're not rushing to buy something, and they live up in a fairly dark part of Southwest Missouri, live an hour and a half away.
Hmm.
And you and I were going, and a group of us were going to a place in Bentonville, a bicycler bar and restaurant to do outreach. And I told them about a good barbecue restaurant in Bentonville and where we're going. So come by, and they show up. So you saw this happen. She looks in a telescope at the sun, and he looks at it, and she stands up and she's like in awe. And then when
Yeah,
it got
yeah.
a little bit darker, we put a 16-inch telescope on the moon. And I wasn't over there with you, but Scott, you told me she took over the telescope and started showing
She took
people how
over
to
the
use it.
telescope. We showed her how to use, focus it, move the telescope, and all the rest of it. We just showed her once, and then she's like off and running, and then she's sitting back with her husband. The husband was supposed to be the guy that was really into it and very interested. I mean, they drove down from another state to be there for this. Okay, um, and this older guy comes up, and she can see that he doesn't know really how to look into the telescope, and she goes up and shows him how to focus it, how to center up the moon, how to do all this stuff. And I mean, she owned it at that point, so
She was
that
all
was
in.
cool. She was all
Yeah,
in. She was all
she
in.
was
So
all
she went over
in.
what I call the tipping point really fast, so that
Yeah.
night
I,
she was reborn as an astronomer.
yeah, I absolutely. She was, and I was talking some technical stuff, how the mounts work and the go-to works and things,
Hmm.
and she was like, but when she saw the sun, it saw sunspots. She was full of
Yeah, that blew
questions,
her away.
and then when she saw the moon through a 16-inch Newtonian or Dobsonian telescope, she was hooked deep, and I think she's hooked. She actually messaged Saturday and said,
Hmm.
"You were talking about that star party in Arizona. When is it? Because we're going." And so, just like, and it wasn't him, it wasn't Eric doing all this, it was Stephanie,
Yeah,
and
Eric
she
was
was
kind of
all in.
quiet
So,
the entire time. His wife was
yeah,
really. That was great. That was great.
yeah, it was, it
Becca,
was.
Becca is mentioning about his first experience. I'll read it to you. He says, "My dad was also very interested in astronomy, and if he hadn't bought those first binoculars for me 47 years ago, I don't know what I would observe with. Uh, but an astronomer would I be what so for? Yeah, he's saying for now on, basically that's when he became an astronomer, and he thinks it's in the DNA. Um,
Uh,
and then Pekka wants
you
to know
know,
when he can send his congratulations video for the 100th. Send it in today if you can. That's great.
yeah, Pekka's been on multiple times as well. So, for
Yes,
sure.
he has.
Oh, and we were talking about OPT. They're an authorized Explore Scientific dealer. There you go. A little plug for them.
Oh
So,
yeah,
support the
one
dealers.
of the first
Support the
ones
dealers
actually.
here. Yeah. So Scott, back go to the FirstLight. The James West Space Telescope.
Yeah.
One thing I think is important to discuss is why it's so much better, and how because all the talk. Well, it's an infrared telescope, and well, why does that work? And Paul, pull up that graphic if you would, please.
Which one?
The
NASA.
Sophie, the infrared from
Okay.
Sophie. So
There
th-
it
There we
is.
there we
go.
go.
And Scott disappeared. Nice.
It's
Scott's the
okay.
magic. He made himself disappear. Okay, so what you're looking at is obviously a constellation of Orion
Uh-huh.
in the visible light, and then you're seeing it in infrared. And so, why is infrared better than visible light? Well, down below that, you can see a spectrum with high energy gamma rays on the left, and then it moves to X rays and UV, and then it shows you the visible wavelength in the spectrum of the rainbow. And then on the red side of the rainbow, it goes into the infrared, and then it goes into radio waves. Okay, so if you start, it turns out that most interstellar dust is about the diameter of the wavelength of light, which means the light runs into all that dust and scatters. So visible light becomes opaque or just totally dissipates when it runs into clouds of interstellar dust. The long wavelengths of that infrared light, it go right through that, go right through it. It doesn't care. It just passes right through. So when we start looking at the sky infrared, we're seeing things in wavelengths that our eyes can't see, but the cameras can capture. And
Mm-hmm.
the James West Space Telescope has a very large aperture, extremely sensitive, very small pixels, giving it some really, really high definition. And that has allowed us to see what was literally invisible to us before. And it brings the invisible, visible. I read somewhere, and I've thought of this. If we could see the night sky in infrared, it would be an astounding thing to see, because around Orion, there's so much infrared and far red glowing. I mean, it'd just be spectacular. But that's why the infrared is important. And that's why we can see through these interstellar dust clouds, because those long wavelengths just go right through it. And so let's go on to some of those images. We've all seen them. But Paul, you want to pull one up? There we go. Is this Stephan's quintet, Paul?
I'm
Yes, yes, it is.
technical
Yes, it is.
stuff on my end.
Yes, it is.
So I wish I'd had time to get the Hubble images scaled and put beside them, but they're out there. I found one on, I'll give a plug for it, NBC News, where they have some JavaScript sliders so you can slide back and forth. The differences are astounding. It's like going from, for those of you old enough to remember, it's like going from a 110 camera to a 6x6 camera. I mean, 110 was the size of your pinky fingernail, if you remember that film camera, and going to a large format camera, the differences are truly astounding. The sharpness, the detail, and what you can see, but that deep field
Oh, yeah.
image is
Yeah,
the
this
one.
comparison that they were showing, the Hubble Space Telescope comparison yesterday on Global Star Party. No, I'll just say there was no comparison. You could see the same outlying shapes and stuff like that, but not to this detail. This looks like, it looks like an ocean wave with incredibly sharp ripples and stuff. And this is a region of starbirth. All these tiny little knots that you see here have embryonic stars in them. Planetary formation is happening. There are disks of rotating dust around stars. It's absolutely spectacular.
Yeah, it's just. I wish I would have had time to get the comparison images together. I just didn't. But
Yeah.
it's like night and it's like you had Vaseline smeared on your camera lens. And Scott, I know you did that to shoot portrait photos to try and soften things a little bit. I
Yeah.
Check
certainly
this
did
out.
that.
So I downloaded the full res version.
Okay,
Yeah.
yeah, I want to see that of the Hubble Deep Field or the James West First Deep
Here we
Field
go.
too.
So here we go. Gonna merge.
So
See how far I went in
Oh,
yeah.
yeah.
for a
Can you go more?
JPEG?
Yeah, it's
Actually, it's a
amazing.
PNG, but I mean, we're in. That's pretty deep.
Yeah. So let's go to that Hubble Deep Field and talk about it for a minute.
Which one is that exactly?
The one with the big square one with all the stars in it, the arcs and stuff.
Oh, I'm gonna have. I didn't get to pull that one down yet, so
Okay.
let me
So
get to it on the web browser.
one thing that that we hasn't seen a whole lot of press and people have been talking about on Facebook before the press conference, on President Biden's press conference, I predicted on Facebook that the spectra of the exoplanet that they took was going to show presence of uh, hydrogen, oxygen, water, and carbon. Well, they didn't have any carbon, but it showed a very, very strong spectral line for water. And the importance of that, the implications are immense because where there's water, there's probably life. And the I know that they picked the best candidate for it. It's a big Jupiter. It's in the Goldilocks zone. It's not super hot. So they picked one that they knew probably was going to have a strong signature of water because of where it was. But it is awesome that the first spectra they got, or at least the first spectra they
Almost got
released,
it.
has water in it, because that is super significant to the potential for being some version of life out there. If you start extrapolating it to, you know, there were billions of galaxies. Now there's trillions of billions of galaxies because this deep field image that Paul's getting ready to bring up, as we all probably have heard, is an area of the sky that's the size of a grain of sand at arm's length. And every dot that doesn't have spikes on it is a galaxy. And it's just truly astounding when you zoom into this thing. All those little arcs are lens galaxies from that large galaxy cluster right in the center.
Yeah, it's incredible.
And so it's lensing.
Give me just a
and
second,
magnifying
and I'll have an even
stars.
bigger image.
Yeah,
Almost every
stars
dot
behind
in
it.
there is a galaxy. I mean,
Yeah, if it doesn't have a spike, from what
but
I read,
exactly,
it's a star. It's a galaxy.
it's a
Now
galaxy.
Get ready.
remember that's a sky the size of angular size of a grain of sand at 3 feet from you, and imagine that all over the sky. How many grains of sand will it take to cover the sky? And it's all there. It's just everything with a spike is a star that's in the Milky Way. Everything without a spike is a galaxy. So that's the lensing galaxy right there in the very middle. I think there's like 5 of galaxy cluster, like 3 or 4
Look at that.
galaxies. Yeah.
There's a
Look at that
spiral
face
galaxy
on.
right there.
Yeah. That's obviously pretty close. But look at over the
Yeah,
left.
and
There's
that
other
one
spiral
galaxy could
galaxies.
be hundreds of billions of stars or a trillion stars.
Yeah.
Probably every star has, or most of the stars have planets. And that's just one.
Look at that.
I mean, look how deeply you can see in this. It's
Yeah, look,
crazy.
and Scott, this is only 12 and a half hours of time. The
Yeah.
longer they stare at this spot,
Yeah, if
the
they
more
did the
they-
100-hour Wade Prunty special, and yeah, I mean, it
even
would
if they
be.
do the first Hubble Deep Field was 11 and
Wow.
a half days.
What's going on
11
there?
days. What are you looking at?
See the blob?
Put your cursor on it.
Which blob?
The cursor doesn't.
That's
There's
my
many.
cursor.
No,
You're
it looks
talking
like
about that kind of orange-looking, stretched-out thing over one of the.
Yeah.
Yeah, that is a gravitationally lensed galaxy.
Isn't it cool?
So,
It is
so what
very
that
cool.
means is, Paul, there's a background galaxy that's vastly farther away, 13 or 14 billion light years away, that's being a very early galaxy formed after the Big Bang, that's being gravitationally lensed and bent and magnified by this big star cluster in the very center of this image. And so it allows us to see much, much farther in the past than we would otherwise. And we've been looking at lens galaxies for a long time. And there's actually people who go through and analyze them and then put them back together and assemble a picture of what the galaxy looks like. And so I'm sure there's people working on this right now. like right there, that big smear that
Yeah.
goes off counter, like a circle going
I
up and to
wonder
the
if
left.
that's the telescope. No, it can't
No,
be, can it?
no,
Because
no,
there's other
that
things that aren't smeared.
right
That's the light being pushed
bent,
around, pushed and pulled.
gravitationally
Bent
lensed by that
by
Yeah.
gravity. Yeah, it's
by
crazy.
gravity, by the massive gravity,
Look at all
which
those galaxies, man.
which
One,
Einstein
two,
predicted.
three, four,
Yeah,
5, 6, 7, 8,
Oh,
9,
just in
10,
this field
11,
right
oh,
here,
12.
you can just go on and on and on.
Yeah, and let me
oh,
show you how
every
much
little
I've zoomed in. Okay, let me put it right back in the middle. How about
and just
Yeah.
that?
start zooming in now. Just start zooming in now again.
I can only take it so far with this software.
Yeah, but go as far as you can.
That's it.
So every single white dot you see
There's tons.
is a galaxy. Is a galaxy, and there's astounding number of little faint white dots in here that just blow my mind. How much? Which I'm
So,
not surprised.
so
There we
let's
go.
just say we have a telescope that can do 4 times this into space. And we see this galaxy. And on that galaxy, there's a little planet. And on that little planet, there's a bunch of people. It wouldn't matter anyway, because that was how many billions of years ago?
This goes back to more than 13 billion years.
Yeah.
Yeah.
So
It would
if
still
you
matter
wave now,
because if I could see that, I would have messed my pants. Okay, and then even though it happened 13 billion years ago, so
can't
It's
go
just
visit,
I wouldn't go.
unfortunately.
Oh yeah, that just it happened a long time ago. It doesn't matter.
Just can't go visit. That's all.
It would have blown my
it's just
mind.
it's the idea. It's just the scale of what's out there is very difficult for we mere mortals to be able to comprehend. The distances, like for instance, if you're going to fly a 747 to the moon, it takes 16 days to get there at the speed of a 747. And that's just, and you thought a flight to Hong Kong, Scott, is what? Is what? 16 hours? We're
From
talking about
here,
16 days. Yeah, from here, 16
yeah, from
hours
here,
from central United States to Hong Kong, 16
yeah.
hours. We're talking about 16 days to
I
get just to the moon.
really like this. This is nice.
You like that?
Yeah.
Okay, so Paul, I'm emailing you a link that Harold Locke sent to me, and this is from the Big Think website. So this is there's a guy named Ethan Siegel, and he is a science popularizer, a PhD physicist, and he is amazing in his explanations. And he writes a blog. He does video programs and stuff like that. I'm going to see if one day I can actually get him on one of our programs. But yeah, you should show this because it shows the comparisons that Kent was looking for.
Working on it.
Thank you, Harold, for passing that along to us. The comparison, it's like explaining what the sunspots look like and then looking at the sunspots. The difference is just immense.
Or explaining
really
what an eclipse is like and actually seeing one.
Yeah, exactly. It's just, you can't do it. It's hard it's just hard.
Right.
But I think, we as amateur astronomers need to seize on these moments and educate yourself a little bit and talk about what you understand and say, I don't know. There's times I say I don't know because, or that's not anywhere that I've done any reading on, because I can try and wing it and BS it, and I'm going to get caught and flub it up, and I don't want to be wrong or that wrong anyway. But it's hard to
Getting
go out and look
close.
at the full moon tonight, because it's going to be bright through a telescope. But go out and my wife is over at a friend's house, and they're going to turn the lights in the swimming pool off and lights in the backyard off, and just swim and watch the moonrise. tonight, and just
Here we go. Ready?
visually enjoy it.
Boom. There you go.
Yeah. So what are we looking at here, Paul? You're looking at the website. What is the? Does it say what the images are here?
This is the James Webb's first science images before and after from the Big Think website. Now that it's fully commissioned, the James Webb Space Telescope begins its exploration of the universe, and here are its first science images.
So it's not saying. I think the top one is a Hubble, and I
No,
think the middle and bottom ones are James West.
no. The three panel, let me look here. It's really opaque, so I've got to get in there and really dig. This three-panel image shows the views of the Carina Nebula's cosmic cliffs seen by, you're right, the Hubble, JWST's NearCam instrument, and JWST's MIRI instrument. With its
Okay, two
first
different
science
instruments, right?
release upon us, the new era in astronomy has truly arrived.
Yes.
Sorry.
So look at that dust. Look at the dust. These are not scaled exactly the same, I don't think. But look at the dust in the top one, the little clouds, which when we saw those images, Scott, from the Hubble,
Yeah,
it
yeah.
was jaw dropping, But as people were teasing, you know, you think the Hubble images were jaw dropping? Wait until you see the JWST, because it's going to make the Hubble pictures look like just snapshots, and that's the case, absolutely the case.
Well,
So
and I have that image. There you go. This is the full res image released, and it's another one of those that I can just zoom forever, and the detail stays.
how big is this? A TIFF or a JPEG? Did you
I
download
got it
this?
as a PNG
Okay,
because
so
TIFFs don't work well on the software. This
okay.
particular image is 47.8 megs. It's
Too
not
bad you
quite as
can't use
big.
TIFFs. Yeah.
Its dimensions are 11,264 by 3,904. That puts it at 7K, 8K. So it's pretty big.
Zoom in there, Paul.
Working on it. I mean, we're in there tight.
Just incredible. Incredible detail. Some artifacts in a couple of places,
Well,
but
sure.
just, yeah, fantastic.
What the heck?
Can you slide it to the left or up or down or something? Go up.
I can a second from now. Hang on. Let me put you guys back up on screen.
And Paul, you said this
There's
is the
even
Eta
more.
Carina.
Huh?
This is the Eta Carina Nebula, correct?
The one that we were just looking at with the comparisons
Yeah.
from Hubble.
Yeah. What's this one? Does it say?
This is James
Same,
Webb.
same thing. This is the same thing. Yeah,
Yeah.
right.
Here's a good question from Pekka. He says, do you think that JWST pictures will affect our thoughts on how deep into space we amateur astronomers can go? I mean, will we change our seeing what to image in the future? Yes,
Yes.
yes, and
Yes.
yes. Hubble
Because
Space
look,
Telescope
you
did
know,
that, and Palomar, the Palomar 200-inch telescope did that, and the 100-inch at Mount Wilson did that, and so yeah, every landmark telescope, that becomes the new thing to benchmark against, and and the thing that's true, and Pekka, you know this, the once you show amateurs something that's out there, okay. Uh, Amateurs will figure out a way to image it, not to this detail and resolution, but they'll go back through their old images and they'll go, oh yeah, I now see it, okay, and then they'll drill down on it and take track and stacking until they get more detail. But definitely, those would be things that amateur astronomers will do. I think that, like Hubble, I'm sure the Space Telescope Science Institute will release the raw data of these images for amateurs and professionals to use. Um, and there will be people that will take one of the images in, black and white image with a lot of detail and use that as the luminance layer in some of their shots, and then bring in their own color, shots that they might do with their own telescopes. And as long as you're telling people that's what you're doing, okay, then there's no harm, no foul. But the moment some amateur claims that they're getting this much detail and they have, nefariously used JWST luminance frame, well, we're going to be able to figure that out pretty easily, I think. Certainly, if you see anything with 6 spikes in it, that's going to be one of the giveaways for sure. But there'll be amateur astronomers that will remove those artifacts and try to own it. But most of us are. I would say most amateur astronomers are pretty darn honest. So.
Yeah, as Harold Locke just said, just as long as people aren't faking their work. We've all
That's
seen
right.
people who get
It
called out on
happens.
Facebook.
Yeah, it happens.
Yeah.
Right. And
So
you'll get found out because amateur astronomers, it doesn't take them a lot to figure out that, oh wow, okay, this much detail, you have done something, Um, so
yeah. So Scott, I'll answer Pekka's question with an example. When
okay.
the Hubble Space Telescope came out and they had that picture of the Eagle Nebula, people were just blown away by it, right?
Sure.
And it wasn't that many years later until people were using, is it Jason Gunzeal with a 152? There's people out there with 152 millimeter telescopes, 165 millimeter telescopes, big Newtonians, who are taking pictures of the Eagle Nebula that, while not as amazing as the Hubble, hadn't tried that before, but yet the Hubble inspired them to go out there and try and do it
Sure.
and see what they could come up with, and came up with some pictures that are astoundingly close to what the Hubble Space Telescope has done. So I think it's going to drive people to think about working maybe more in the deep, far infrared and trying to figure out ways to modify sensors or enhance what they already do.
And to get the resolution, certainly you can shoot at longer focal length in the mosaic. Now, these are things that pros don't do so much because they need, they need to be productive. They need to be going on to the next thing. They're gathering images for science. They're not doing it to try to get it on the cover of Sky and Telescope magazine, for example. Okay.
Right.
But amateur astronomers, they own their own equipment. This is the advantage. And you can go for a long focal length, shoot a small section of, say, like the Andromeda Galaxy, and then move over, and another small section and move over. And, it's not quite the same as having the larger telescope, but you do get incredible resolution and unbelievable detail by doing that. But it can be a project that you spend the better part of a year on. So,
yeah, I look forward to see what people come up with inspired by this in the next couple of years to try and start adding, some really deep infrared to their palettes and going back and adding it to stuff they've already shot.
Yeah. Unfortunately, our atmosphere is the problem with infrared. So, one of the places that you could go as an amateur is Mount Wilson. They have one of the darkest infrared skies in the world.
Really?
Right next
Why is that?
Pasadena, which is super light polluted.
Why is that, Scott? Why is it not got an infrared pollution? Any idea?
Because they don't light up cities with infrared light.
Yeah.
I mean, that's one of the simple answers right there. So,
yeah.
I mean, if they did, it would
they're
be
out
really light polluted, but they don't, so, um, but it is, that's the reason why the Chara array is there, and it's an all infrared system as well. So,
it's
Look at
or at
the
that.
least
more
they can see into the infrared.
Look at that. That's
that's little spirals and
Spirals. The thing
globular.
looks like there's a cross, but I think it's a couple of colliding galaxies,
Yeah.
maybe more than two colliding galaxies,
huh.
and it just goes on and on. There's a barred spiral out there. But every speck, I mean, even down to what looks like a tiny salt speck, there is a galaxy.
Yeah, every single pixel that has some light on it is a
Is a
galaxy.
galaxy.
Is a galaxy.
That's mind blowing.
It because again, this is a fraction of a degree, a tiny fraction of a degree of sky.
And I'm doing a fraction of that.
Yeah, and just spread that out over the entire sky, just truly astounding, astounding. So,
So
all
Connor
right,
wants to
so
know, what are my thoughts on flat earthers? I feel sorry for them. That's all. So,
and you
that's my
can't
thought.
argue with them. You can't. There is
No,
no
that's a
way to
belief
convince them.
system. So, there's no science involved here with flat
Right.
earthers.
So I think it'd be fun to talk Elon Musk into sending the two top flat earthers, the two preeminent flat earthers, send them to the ISS, let them spend a couple of days there, have them come home, and see what the impact would be on their belief system. If
But
they then came back,
we can't, Kent, because the ceiling is too low.
I understand, Paul. That's why it would be fun to have them to send some up and let them literally go around the Earth in a circle. The fascinating part is the ancient Egyptians knew the Earth was round. A guy used a well and a measurement of distance, an angle of light going down two different wells to get within. He was within less than 10% of the circumference of the Earth. What, 3,000 years ago?
Hmm.
And
Is that a galaxy of galaxies?
You mean all those galaxies there in the background?
No, in the bottom middle.
zoom
What
out.
is that?
It's a foreground galaxy,
Yeah.
probably.
These are all different distances and stuff. But again, everything that doesn't have spikes on it is a galaxy.
Is it a galaxy of galaxies?
No, that would be a star. That would be a galaxy
Well, you're
cluster.
asking me,
And
is it a
there are
group of
galaxy
galaxies?
clusters.
And yes, this is Stephen's quintet. I think four of them are actually. Is it three? That's
There's
Well, there's
three of them are
four.
gravitationally
three are
right.
yeah, and one of them is a foreground galaxy. So I don't know which ones are which.
Yeah,
So
either a foreground or a background. But yeah, there's three that are actually gravitationally paired, and then another one that is either close or closer or farther away.
mhm, mhm.
So,
Wow.
and you can see those. I mean, under dark skies, there's lots of people take pictures of them. You can see those under dark skies with your naked eye. It's just amazing to sit there and go, okay, I'm looking at that, but then
Yeah, I've
in
seen
that
this.
yeah, but draw a square on that, and in that view that you can't see because they're so far away, are literally hundreds of more galaxies in that tiny field of view up there. So,
Yeah.
all right, Scott, it's 5 o'clock. Up here's Alfred.
I turned
Here's
into
a thought.
we're turning into a pumpkin. So,
If we
anyways,
do live in a fabricated universe, the programmers will have been working hard recently to write software to allow the JWT to show new stuff. Interesting thought there. Yes, that we're all actually just in the matrix. So, it's a steady state of galaxies. Rainbow harvest. We have some names I haven't seen before. It's awesome to see new people joining
yeah,
us
thank you
here.
for watching.
I tell on my Amazon Live and my social media broadcast at 1:30 and 2 o'clock, I literally thank them for giving us their time, because they are sharing their time with us, and that is a blessing to us.
Yeah.
Right. Yeah. So Mike Wiesner says we'll see Quintet at Arizona Dark Sky Star Party. Thanks, Mike. So Mike is the lead on that. If you're interested in the Arizona Dark Sky Star Party, you can go to the Explore Scientific website and search for Arizona Dark Sky Star Party. It's $150. Register for the ticket. That's going to get you lectures, access to the park at night, camping in the park. It's going to be tent camping in the park. You won't be able to bring an RV, and then you're going to have to stay there somewhere if you're not camping in the park. Biosphere 2 from the University of Arizona
Yeah, the
has
casitas.
has housing there for people to do research, and we can reserve. You can get they're like bedrooms with a central communal area. $520, which is like $120 a night or something like that. You're going to pay that for hotel or bed and breakfast, or there's Airbnbs and bed and breakfast around Oracle as well. Um, get out there. If you don't bring a scope, don't bring a scope. We're going to have some scopes out there. There will be plenty of people with scopes. And if you're just interested, just bring yourself and bring your curiosity. September 21 through 25, Oracle State Park, northeast of Tucson, Arizona. Pristine, dark skies.
Yep.
It's going to blow your socks off if you've never seen it before. Worth the effort to come to it. Pekka says, read about Linakia, our local supercluster, but there are a couple of more and how they move in the universe. Yep, absolutely. Scott, any closing thoughts?
No, I just look at all those galaxies. They're kind of filling my mind right now. I'm sure, just like everybody else that's interested in astronomy and stuff, uh, it's um, it's made us all jubilant, uh, kind of filled with wonder, and really anticipating what's coming next. Because they just scratched the tip of the iceberg of what they can do with JWST. So.
Yeah, yeah.
Yeah,
Well,
beautiful image, and yeah, you could just stare at that image all day long. It's crazy, but we got work to do. So just burn this into your brain, so that you can shut your eyes and still see it, and uh, and keep looking up. Thanks,
thanks,
Scott.
Scott. Bye, everybody.
Thanks.
Hey folks, Sean here from Visible Dark on YouTube and visibledark.ca on the web. Just want to send a big congratulations to Scott and Explore Scientific on the 100th episode of the Global Star Party. Fantastic stuff. Keep up the great work. Here's to 100 more.
Howdy, Scott, Explore Alliance, Astronomical League, and esteemed Global Star Party friends. This is Cameron from Camp Astronomy, wishing you all a hearty congratulations on our 100th Global Star Party. Keep looking up and enjoy the journey. Cheers.
Don't.
Hello, everyone. It's Bob Fugate from Albuquerque, New Mexico. Congratulations to the Global Star Party on achieving 100 exciting episodes. Please keep up the great work. Thank you.